We're continuing on the lesson on, we're recording now by the way, we're continuing on the lesson on, what is it? Graphing circular functions. So you need your calculators for a fair bit of this, so make sure you've got your calculators out. So I've got it there. So yesterday we did sine graphs and cos graphs. So sine graphs, remember, kind of starts at 0 and go up and down, and because it's all about the height of the triangle as you go around the point P. The height of the point P as it spins around the unit circle will follow the shape. And then the cos is the horizontal distance of point P from the origin. So that's why it starts at 1, hits 0, hits -1, hits 0 again, and then goes back up to 1. So they have, and remember we were looking at the fact that these graphs, we moved on from the subject, you just need to get it. These graphs have periods and amplitudes. Period is the length it takes to do a whole cycle. So for example, you could look at it from a sine graph perspective, it's like from the 0 point to the 0 point. If you look at it from a cos perspective, it would be the maximum to the maximum. So it'd be the 0 to the 0 point, or if you're looking at the cos, it's the max to the max, and so on. And the principal axis is kind of halfway, so an imaginary line halfway between the top and bottom. And the amplitude is kind of like the length from the principal axis.
Sabemos.
Did you say something in Spanish? What was it?
Sabemos.
Yeah.
We know.
Oh, really? I've never heard of that word.
You go to the town.
Oh, okay, it was part of the gag. Even you were down. Yeah, so and then you got minimums and max and all that kind of stuff. So these ones we looked at the amplitudes and the periods of them. So amplitude is kind of like 4 for this one, it's cosine, and it's got a period of 4 pi. This one, notice that from the 0 point to the 0 point, the principal axis is here. So from here to here it was a distance of 2 pi, and its amplitude was 2. If you're looking at it from a sine perspective. If you're looking at this one from a sine perspective, you could think of it as being negative sine. So that's why we had -3 as the amplitude, and the period from here to here is 4. Whereas if you looked at it from a cos perspective, then the amplitude is just 3. So it would be 3 cos, or it would be -3 sine kind of thing. And then now we're going on to something next. Oh, tan graphs. Tan graphs look nothing like sine and cos graphs. Have you ever seen that?
Never.
That's a tan graph.
I've never seen that.
Isn't it weird? Doesn't look anything like a sine or a cos graph. So in year 11 GCSE exam questions, there were some that were based, probably saw a lot of sine and cos graphs in your GCSE exams. But in IB you also need a knowledge of tan graphs. Tan graphs was officially in GCSE as well, but you rarely saw it. These graphs look totally different to sine and cosine. Mark in any vertical asymptotes, and here we're going to describe why they have asymptotes, vertical asymptotes, and describe any features you notice in the space below. So by the way, so these previous ones, like if it's a regular sine graph,
Chuck Norris.
no, if it's a regular sine graph, what is the period for a regular like sine?
360.
360, good. Or if it was in radians?
2 radians. 2 pi.
2 pi, yep, exactly, yeah, 2 pi radians. Same thing for a cos. What would its period be for a regular cos x?
360.
Yeah, 360, good. And in radians? 2 pi radians, yep. Whereas the tan graph, so one thing that we've got to notice about the tan graph, where are we? What's its period?
Its period?
Yeah, so notice it from this point, it starts to repeat again here.
Yeah, look at 180.
Oh yeah, it is 180. I was like, no, it's 180. Yeah. So notice it's not the same as sine and cos. So the periods are like half the size of the length of the sine and cos ones. So the sine and cos ones were 360, whereas tan repeats every pi radians, or every 180 degrees. So that's one thing we can note down here. I'll just write. I can note that. Let's just check out how bad the board is first. So period of tan graphs. So if this is regular tan x, period of tan x is 180 degrees, or 2 pi, no, pi radians. 180 degrees, or right down here, pi radians. Whereas sine x and cos x have periods of 360 degrees or 2 pi radians. So that's one comparison. So the periods are different to sine and cos graphs. Sine and cos graphs have, like if it's just sine x or cos x, like you don't vary like anything, then you just have periods of 360 or 2 pi. Whereas tan x is 180 or pi radians, is that stuff. I'll zoom out a bit because we need to, for this one, we need to see a bit more of the graph. Okay. And the other thing, I'll just quickly zoom back down. It wants us to draw in any vertical asymptotes. So we described a feature already. Where do you reckon you see an asymptote? There's a little clue is there's something like 4 of them.
90 to 70,
Yeah.
50,
Yeah.
negative 90.
Yeah, good. So there's 4 of them actually. Notice the equations are
Oh, they're
really
right
good.
here. I don't know.
Yeah. So the good thing, yeah, but you wouldn't expect me to realise that. So the equations are written in for you, but they haven't drawn on the graph the asymptote. So there's one there. Notice they put in the equation for you. So, whereas sine and cos graphs don't have any asymptotes. They only have vertical asymptotes, these ones, but sine and cos graphs have no asymptotes. And notice the asymptotes are every 180 degrees. So that's another thing we'll write. And here soon I'm going to sort of help you realise why they have asymptotes. I'll just save what we've done. Oh, whoops. Didn't mean to close that. I meant to close this one. Now I just need to zoom in a bit. There we go. So we've got the 4 asymptotes. Another thing, if you've got any space, I just write, they have vertical asymptotes. Tan x has vertical asymptotes every 180 degrees. Has a vertical asymptote. If it's just a regular tan x, asymptote every 180 degrees or pi radians. Have I done that right? It is every 180 degrees, isn't it? If I just imagine the wrong thing. Let's see, between 90 and negative 90. Okay, good. Thank you for checking. Yep, and between 90 and 270, it's 180 degrees. Good. So that could do for the features. If you've got any space, or you could just look at it and realise, you notice that they continue infinitely down this way, and continue infinitely up the other way. I'll just zoom up. I'll scroll up. Some people are writing these, so I'll just let them write it first. They kind of continue down infinitely. Sine and cos graphs they don't go up and down infinitely. They kind of like have a definite max and a definite min. Do tan graphs have maxes or mins?
No.
No, they don't. They just continue on always up that way. And
But they have a
infinitely down that way.
POI. Did they on there?
Is it a POI? That's a good point. Is that a POI? I can't remember. I was thinking that and I thought I need to confirm that because it looks like a POI and I can't remember if they are POIs.
You guys, we should fit in the joke.
Oh, yes. Okay, I'll check that POI ID for you though, just in case I'm wrong. Okay, so that's right. Sine and cos graphs have definite maxes and mins, whereas these ones go up infinitely that way and infinitely down that way. So there's no max or mins. If you've got space, you could write that too. So first of all, why are there vertical asymptotes in tan graphs? So remember back to the trig identity. And I'll just quickly need to calibrate again because that's a small box to write in. What was the trigonometric identity again, if you follow that? From the different trigonometric identities, what was the trig identity? It's not the Pythagorean one. Yeah. Good, yeah. Sine theta over cos theta. So good. So this is so the trig identity, and Felice said, is tan theta equals sine theta over cos theta. So this is why we have asymptotes. Asymptotes are regions where the function can't exist. And only...
Learn something new every day.
So,
Chuck Norris.
Chuck Norris, that's right, yeah.
She was asking me because I was the one who got it before.
And only Chuck Norris can divide by 0. So when
Can he? Can he even do it? Yes.
So whenever, what thing has to equal 0 for it to be undefined?
The denominator.
Yeah, and then so whenever cos theta, so whenever cos theta, the denominator basically equals 0, tan theta is undefined, as then the denominator would be 0. So remember, cos theta is the horizontal distance of point P. Is cos theta 0 at 0 degrees?
Cos theta, yes. No, it's 1.
Good guess. Yeah, good. What about here?
0.
0, good. So at 90 degrees is 1. What about here? What's cos theta there?
-1.
Negative 1. Good. What's cos theta there? 0. So see, what's cos theta there when we go back?
Wait, theta? Theta.
What?
Theta is the thing again.
And what's the next one's 360 plus 90 is 450 degrees?
Yeah.
0, yep. So 450 plus 90 would be 340 degrees? No,
Negative
540 degrees. Yep. And 540 plus 90 is 630. Yeah, so notice, so you're sort of seeing why we're getting asymptotes?
Why?
Because on the unit circle at those particular values, on the unit circle, cos theta is 0.
There were
You see here, cos theta is 0.
at 90.
Yeah, and at 270. Also, if you went backwards, if you went back negative 90, that would be here. So cos theta 0 is 0 there as well.
Negative
Yes, negative 270. Or so 90, 270, 450. What's the other bit? 630, whatever it was, 630.
Great
Yeah.
math.
Yeah, good. So that's why we have asymptotes, because of the fact that whenever cos theta is 0, the function's undefined, is why we get that kind of thing. So just in case you were wondering, because it's just so interesting. So you might want to make a note if you want to, there are no maxes or mins on tan graphs. Maybe that's one last thing to say. So there are no max or mins on tan graphs. But there are on sine and cos. Yeah, there are on sine and cos graphs because those ones kind of have definite tops and bottoms. Those tan graphs don't. That was meant to be a sine or a cos graph. Tan graphs are weird.
So we would never be asked what the max or min is on a tan graph?
Yeah. The only time they could is imagine they narrowed down the domain so that it was only from here to here.
Oh, okay.
And then
it would just be your, like the highest. Yeah.
Yeah, exactly. So imagine in the question define the domain as being negative 45 to plus 45. So the max would be there.
The max would be
Nah, yeah.
45.
No amplitudes, yep. So there's no amplitudes or anything for tan graphs. Huh? Yeah, exactly. So it would be where whatever, yeah, exactly. It would be cos 45, wouldn't it? Yeah, you're right. So that would be the only case they could ask for a maximum is if they defined the domain so that there was a clear maximum. So these things here are, by the way, just to help you with that. Am I on the next page or did I miss something? No, okay, cool. So these things here I've just popped at the top because they might help you. Rather than have to draw it out and explain it, I thought I'll have them there. So get your little graphing calculators out because they're awesome. And, and you're going to do some graphy stuff. Use your graphing calculator to solve the following. Sine x equals 1/2 for negative. Huh?
You're shouting.
Oh, yeah.
I thought you were shouting because I was talking.
No. I don't know. Yeah, just got really excited.
Sine x is half.
So, how would you use your graphing calculators to solve these? Anyone?
Y.
Yeah, good. Y1 and
Y2.
yeah, good. Because then y equals 1/2. Would you agree? It's just going to be a line
Yes.
that cuts between through a half.
Maybe.
Come on, everybody.
And notice I've defined it as from negative. So notice I've defined it from negative 90 to 450. So make sure that your window is just negative 90 to 450. So out of interest, how many solutions do you think there's going to be?
Question: if you put it in radians,
That's a really good point. Does this look like radians or degrees to you, this one?
Definitely looks like.
Oh yeah, this one I mean, sorry, yeah, this one's degrees. And whereas this one's going to be in?
Sorry.
That's a really good question. I'm glad you asked that, because make sure for this one that your mode is in degrees, and the same to this one. Make sure for this one that your mode is in
degree radians.
radians for this one. Yeah, for the last one. Because that will see that if it's got the fact, if it's described in terms of pi, then it's in radians. So how many solutions are there going to be?
A couple. A lot.
There's going to be 1, 2, 3. Yeah, so I'll just make a little note. You're going to graph in Y1. So let's make a note. Graph in Y1. So we're going to graph that one in Y2. We're going to graph the other one in Y2. And then, so I'm just making little notesies on what stuff you might want to record as being things to remember. You guys do your graphy graphs in the meantime. So graph in Y1, graph in Y2. You need to make sure your mode is in,
It's for learning.
Okay, make sure. So, come on, good. Make sure your mode is in degrees, because of the nature of the domain. The domain was written in terms of degrees, whereas for the last one, your mode has to be in radians.
No, check.
Go quickly. For this one, make sure, for that one, just be aware the mode would have to be in radians for that last one. Whereas for these two, it's in degrees. That's meant to be a calculator button.
Mine looks weird.
Yeah, it was radians and it looked like this, but when I changed to degree, it was like
Straight lines.
straight line.
Like that.
Oh yeah, so another thing. Oh no, I'll show you even better. So even better than that. Even better than Zoom Tree.
I did that in your window.
Put that in the window, yeah, good. Yep, so pop it.
I did that and it still didn't look right.
And make sure your mode is in degrees.
Did that and it still didn't look right.
So your x-min equals negative 90. Your x-max
No, I didn't. Did you do
equals 450. And notice that your y, like if it's really flat, you could adjust it so that your y-min and your y-max is a bit smaller. So your y-min could be negative 3 and your y-max, or even negative 2, just so you can see it a bit better. If you do negative 10 to 10, it'll be really condensed down.
I did alternative window one.
But I alternated when you ended the negative.
Yeah, exactly, that would be fine. Because your line's going to go through negative x. I mean, half x.
Perfect.
So let's see. So I've got to make sure my mode's in radians, so that's an issue. So I've got to change it to degrees.
Maybe that's what.
I've got to go sine blah blah.
You said that.
And see, I've got 0.5. My window, see my window I'm adjusting. Window I'm adjusting from negative 90 up to 450. If it doesn't give you a domain, thank you. If it doesn't give you a domain, please stop talking, thanks. If it doesn't give you a domain, then what Talise said of Zoom Trig is a good thing. So here it gave you a specific domain, so we should put that one in instead, negative 90 to 450. As I said, if you do negative 10 to 10, which is the default setting, you can see it fine, it's just a bit squashed. So if you want to see it better, you could make it negative 3 to 3, or like Bella did, negative 1 to 1. I'll do, like for example, negative 2 to 2, or negative 3 to 3 is fine too. Negative 2 to 2. Graphy graph. And then once we've done that, how do we find the solutions?
We get the intercepts.
Yeah, how do we do that?
5. Count 5. Trace count 5. Second
Count 5.
Good,
No,
yeah.
I'm a G though, because I just guessed it was 5.
Second calc 5, yep, intersects. And then what do we do?
We make it one whenever it's close to it.
Yep. And then go?
Enter.
Yeah, 3 times, yep, good. So one solution is 150 degrees. So how many other solutions are there?
2.
150 degrees.
So what do I do then? Tell me what to do, Lauren.
You go over to the next one that you think.
Yeah. Or sometimes I do second calc 5 first.
So I would go to the first one.
I know. I've really annoyed you. I've really annoyed you all by not doing
Like in
that.
the second one.
Okay, so 30.
Mhm.
And then do you guys arrow first, or do you go second calc and then
I
arrow?
put second calc then arrow.
Yeah, I do too. Because I found when I didn't do second calc and then arrow, second calc intersect, then I just kind of went back to the old one for me.
Did it
Yeah,
matter?
I just move on and press.
It literally does that to me too.
You do that too?
Yeah, and whatever you do, don't press trace because trace will be slightly inaccurate.
Yes, it would be.
390. So I've got our 3 lovely little solutions.
For the most ones.
Oh, here.
It's just when it was negative 10 to 10, it was hard to see that there were 3 solutions.
Okay.
So the reason why I zoomed in and made it like not negative 10 to 10, which was the default setting, was when it was zoomed out, I couldn't see that there were 3 solutions easily. So that's the only reason why I kind of zoomed it in. I did that.
Second calc 5.
Yes. And what was the last one? X equals
390.
390 degrees. But don't forget your little degree sign. So if you want to write your little instructions for however it makes sense to you, you might forget how to do it. So second calc intersect. I hate you, boy. Second calc intersect is all I just wrote.
Other one more.
And then just try the next ones. Practice doing the next ones. You don't need to write out all the instructions this time because I just wanted one set of instructions for you to be able to refer back to.
Miss Fernando.
Yeah. So this one, should my mode be in degrees or radians?
Degrees.
Yeah.
Degrees.
And is it 0.3? No, it's negative 0.3.
Wait, 30? 30 then 150 then 390.
Yes.
Yeah. And don't forget your little degree sign as well.
Yeah, really mark you down for not having a degree sign.
In a way, like you just don't want.
Well, it's not the right answer.
Yeah, it's like not putting centimeters. And they can, like, it's such a shame to lose marks for something as small as that.
That would make
It's like units. It's like not putting centimeters. Because maybe they're not sure. Is it radians? Is it degrees? So how many solutions are in this one?
3.
Is there?
2.
Oh, you might have been looking at the x-axis.
Again, I just have a straight
Yes, yeah, just do. Oh, so you might be, like, check your window.
No,
Maybe.
no, we do it. I like to troubleshoot.
Oh, sorry.
No, I was talking to kids.
Oh.
I knew what you were going to say there. My window is in negative 90, then 450. Why is your Y? Does it matter about Y?
Yeah, if you're too zoomed out, you might not see it. So,
It's too zoomed out.
yeah, because notice this is a tiny
I'm
number.
already at 8.4.
Yeah, negative. I did negative 2 and 2. Just because negative 0.3 is going to be like, really close to the x-axis. So I wanted just to be able to see how. The main thing is you want to be able to see how many solutions there are. What do you get for your little solutions?
I hate
Cause X.
You ruined it.
It's funny. I think I've done something wrong.
Check your mode. Are you in degrees?
Radian.
Oh no, radians is not until C. So see, this B is in degrees.
Oh no, I just put it in. I'm doing C now.
Oh, you haven't adjusted your window yet. Your window is in terms of 90.
Oh, so I can
Yeah.
put in the 4.
You actually use the pi button and the fractions. Yeah. Yeah, it's pretty cool.
Miss Melanie, what should my X scale be? Can we finish B first?
Yeah.
Oh, we doing VLC because it's writing.
I just leave it as the default of 1, like whatever
Okay,
the
mine's
default
still
setting is.
90, so maybe that's.
Oh yeah. So that might be something.
And your Y scale should be 1.
Yeah, that's a default setting, and the X-res is 1. So you got 2 solutions. What answers did you get for these ones? These 2. Yeah, what did? Any answers to these ones?
Yes.
To 366?
So, and 107. And then 253 if it's to 3 sig figs.
So these are, I've got the same answers as Lauren, so just check that you got the same answers as us.
That was sad.
Oh, was it? Oh, so,
I am too good.
no. So here's -1. If you were to draw it, like just pointing out that if you happen to want to draw it or something.
haven't done it yet, that's why. Yeah, I put the
So that's why there's two solutions.
Rain,
but I still had some I never made them a lot of equations.
So now what we've done is we're equating tan x. What kind of function is this?
A tan one.
No, this one here?
Yeah.
Linear. Good. What's its y-intercept?
It's a -1.
-1, and its gradient's like 0.5. What mode do you need to be in? So guys, make sure. Oh, sorry, you're helping each other. Radiant, good. This next one's kind of hard, so shh, please be quiet just while I know you're doing your work, which is great. What do I need to make my mode for this one? Radians, yep. What about my window?
That.
Yeah, exactly. Make sure your window's not -90 to 450. Make sure you put in this thing. Like use the pi button. So otherwise you'll get a crazy looking graph. So be really conscious of what mode you're in.
Bloody murder.
I had that too. You put
I know, yeah.
Hey, what happened?
And X.
You got murdered?
Oh, I'm so dumb. Is that gonna be the answer?
Here's what we're talking about.
It's not mine.
So I'll show you.
I have moon and I don't black on box. That's moon. The shuttle.
Okay, guys. What should I put in for my X min?
The X min should be pi over 2, so -180.
Oh no, it needs to be in radians. You need to put in exactly that.
So then just put that.
-pi.
Good. Yeah. So negative. Here's the pi button.
2.
Good. Yeah. -pi.
Why don't you do
I do-
alpha y equals?
Does it work? I found alpha y equals didn't work for me.
It works for mine.
Oh, if it works for yours, then do it. Yeah. For mine, it wouldn't let me do it.
Okay, it doesn't work for mine. What I do?
I just did. Sorry, I just did -pi. So Kiesia, I just did -pi divide by 2, and then it worked okay. And then for this one, yes, young Lauren.
Isn't that just -90 degrees?
It
So it's hard to
doesn't
do this all
work.
in degrees.
Nah. Oh,
Could we just convert it over?
your answers have to be in radians.
Okay.
Yeah, that's a good point. So your answers, by the way, because of the nature of this, your answers should be in radians.
Wait, so why does it convert?
This is what I grabbed.
But if it's -0.
Did you change your window?
Yeah.
Look at my graph, Mr. Lenny.
What are you saying?
How do you convert -0.97?
Oh, you just write 0.980 radians. And write zero. You can write rad if you want.
Oh, so it's given to you.
Yeah. So you write rad. Just be aware when I graphed it, I can see this solution, but there's probably one up here I can't see. So
Zoom out.
yeah, or yeah, you could do that, or just make your Y max a bit bigger.
That's
Like-
what I meant.
Sorry.
So you put -pi over 2.
Yeah, -pi divide by 2, because I can't do a fraction on my
Me
in my
either, I
window.
was playing.
No.
I just thought I could.
That's fine.
Did it give you -1.577?
Yeah, something like that. Yeah.
Yeah, that's good.
There you go. So now the good thing is I can see them all, and then you can do your second calc intersect.
Yeah, I do.
So notice it'll give you a yucky decimal. So just do it to 3 sig figs.
Sorry.
And write the word radians afterwards. So it gives you a yucky decimal. So you just need to write it to 3 sig figs and then write the word radians or rad afterwards as your answer.
So what you put your Y thing is?
So good.
Y.
Oh, I did 10. Y max is 10 because otherwise I couldn't see
Me either.
the last thing. So Y max being 10, that's like more than you need even. 5, and then I'm going to go over to the other one. Notice one of them's -x, so just be careful. The first one's actually a negative answer. It's hard to see though on here. Yeah, see -0.980 and so
You
on.
should also make your Y min a bit larger because you can't see it.
Yeah, you need to be able to see the crossing, yeah, where they cross. Or else I won't find you. So you can just write red if you want. What's the other one? 397. Oh no. Yeah, I was just trying to remember that it was 3, you got it right. 3.90. Yeah, good. So I forgot to write red on mine, so just make sure you do red or radians. In Australia, we kind of write radians like you know how you write degrees? In Australia, we write radians like that. But I don't think they're used to that in IB. So just write red, because the person marking your exam might not know what that C is. There is. What is the third one?
7.541.
That's pretty painful, but now you've seen how the importance of being in the right mode and of adjusting your window to match the domain, which is the case for functions too. You need to match, when you do regular functions and graphing, you need to match their domain in the window manually.
Yeah.
That was fun.
Yeah, so much fun.
Is that the last one for this?
Yay.
That's the last one? The next one's the next one, isn't it? Okay, so you guys just write stuff down, have a little break while I just quickly convert this video. Maybe.